Every single second of every day, our municipal infrastructure catches the relentless, unceasing runoff of human civilization. For decades, the Northern Periphery and Arctic region has managed this through a strictly linear process. Facilities consume heavy amounts of energy to sanitize the water, then spend significant capital to dispose of the residual sludge. Across this geographical expanse, wastewater treatment plants act as active energy trains on municipal grids. This method actively discards enormous volumes of value. Every ton of unrecovered sludge represents lost potential for biogas energy and squandered agricultural nutrients like phosphorus and nitrogen. Within this standard operating model, utilities remain strictly public cost centers. As value bleeds through mounting energy costs and disposal fees, these facilities become economically unsustainable. To address these economic and environmental inefficiencies, the Interreg Northern Periphery and Arctic program launched Project Enforce in 2022. The objective is to move away from linear disposal and transform traditional municipal waste facilities into localized resource recovery plants. This project is driven by a multinational consortium anchored by the University of Tromsø, University of Galway, Environment Agency Faroe Islands, and Arctic experts. Their focus is on harvesting specific market-ready outputs, biomethane for grid energy, and struvite and nitrogen compounds for a circular bioeconomy. We are mapping the exact analytical pipeline used to execute this transition, starting with high-level steep macroeconomic drivers, down through ISO standard life cycle assessments, and finally into hard cost-benefit analyses. Converting heavy public infrastructure requires a rigorous mathematical framework to prove techno-economic viability before a single plant is retrofitted. Arctic Experts applies the STEEP framework to map these forces, analyzing social, technological, economical, environmental, and political factors. On political and environmental fronts, EU Green Deal frameworks now mandate nutrient recycling, making traditional disposal illegal. Economically, volatile electricity prices mean energy-draining plants will threaten municipal budgets. Simultaneously, advancements in automation, digital monitoring, and urban agriculture are providing the technological and social means to utilize these recovered materials. Ignoring these macroeconomic drivers ensures the rapid obsolescence of the traditional municipal utility model. However, applying a single engineering solution across the Northern Periphery is impossible due to massive infrastructural and geographic disparities. At the highest end of the capacity spectrum, consider a facility scaled for a 150,000 population equivalent, capable of advanced biological treatment. A 150,000 PE facility generates 1.64 million kilograms of dry sludge yearly. Handling this requires heavy capital. Hardware evaluation shows stark price differences, contrasting a €330,000 Alpha Laval centrifuge against a €202,000 Kleintech filter press. Now contrast that industrial, high-capacity scale with the baseline reality in the Faroe Islands. The Faroes currently rely on decentralized septic systems and direct marine outfalls with zero resource recovery. Even in established Norwegian municipalities like Tromsø and Bodø, large sections of the pre-1970 pipe networks suffer from severe leakage, diluting the effluent. Because baselines range from hyper-connected biological plants to isolated marine outfalls, the Enforce methodology uses a dynamically scaling model to calculate localized feasibility. Localized feasibility is processed through a three-tiered evaluation engine, starting with an ISO standard life cycle assessment. This LCA layer quantifies how much greenhouse gas is reduced and tracks the mitigation of eutrophication risks in local fjords. That environmental data feeds into the second tier, the techno-economic analysis, or TIA, which evaluates the financial gravity of the transition. The TIA accounts for the heavy initial capital needed to retrofit legacy facilities with anaerobic digesters, struvite reactors, and smart monitoring systems. It weighs capital costs against massive operating expenses. OPEX data for a 75,000 PE facility shows annual polymer consumption costs over €61,000. But the staggering cost is disposal. Transporting wet sludge off-site costs nearly €224,000 annually. The final evaluation tier is the socio-economic analysis, measuring regional gains like local green job creation and the reduction of the farming sector's reliance on imported fertilizers. The TEA funnel proves that securing long-term OPEX reductions by producing on-site energy and completely avoiding disposal fees is the only way to justify the high initial retrofit capital. The raw data output from the TEA is then structured directly into the Enforce business model canvas. This canvas redefines the wastewater plant's value proposition, shifting it from a public waste service into a commercial resource hub. It outlines the specific product sales replacing traditional waste logistics, biomethane prepared for grid injection, and recovered phosphorus products like struvite. Utilities must target local agriculture, fertilizer distributors, and district heating operators. To execute the physical upgrades, the canvas maps how green funding subsidies and carbon credits plug directly into the cost structure to offset the investment. This canvas is an actionable financial blueprint. It provides the exact economic modeling municipalities require to secure EU or state development funding. The culmination of the STEEP scenarios, the LCA, and the TEA results in a unified cost-benefit analysis. This final output prescribes distinct application configurations based entirely on the region's localized baseline data. Configuration A optimizes large-scale anaerobic digestion for biomethane injection, engineered for dense urban centers. Configuration B targets decentralized wastewater heat recovery and localized sludge treatment, like pyrolysis, designed for remote island communities. Configuration C prioritizes targeted nutrient extraction, specifically struvite recovery, for regions with heavy agricultural overlap. By mathematically evaluating these specific pathways, the Enforce protocol removes administrative guesswork, providing validated transition blueprints to municipal planners. These localized facility transitions serve the larger geopolitical goals of the EU Green Deal, pushing the continent toward greater supply chain autonomy. This transition allows municipal infrastructure to move away from isolated disposal plants and toward distributed nodes for local energy and nutrient generation. Utilizing municipal effluent as a consistent resource allows utilities to stabilize their regional supply chains. The Enforce protocol provides the mathematical evidence needed to position wastewater as the primary raw material of the Northern Periphery's emerging circular economy.